Point at the moon tonight, and it looks close. Close enough to reach. Close enough that people have always drawn faces in it and called it a companion. That is the first lie the sky tells you. Because the moon is so far away that a scream, if space could somehow carry it, would take about 13 days to arrive. Aim that same scream at the sun, and it would travel for about 14 years before it landed. Send it across our own galaxy, and it would take roughly 87 billion years, more than 6 times the entire age of the universe. There has not been enough time since the beginning of time for a human voice to cross our galaxy even once. And here is the part that should quietly unsettle you. There is no wall out there. Nothing is stopping us from crossing these distances. Nothing at all, and we still cannot go. Get comfortable. Hit subscribe if you're new here, because by the end of this, the empty sky above you will feel less like a ceiling and more like the gentlest cage ever built. A cage with no bars, made of nothing but distance. Now, let's slowly ease into this. Part 1. The last familiar distance. Somewhere in your memory, there is a distance that once felt enormous. Maybe it was the drive across the country you took as a child, hours dissolving into a blur of highway and window glass, the back seat becoming a small country of its own. Maybe it was the first time you flew over an ocean, watching the coastline slip away beneath the wing until there was nothing below but water in every direction, and you understood, in a way you never had before, how much planet there is. Maybe it was simpler than that. Maybe it was just the walk to school, which at 5 years old felt like an expedition, and which you later realized was almost nothing at all. Whatever that distance was, your mind knew what to do with it. You could hold it. You could feel its size in your body, measure it against a day, a tank of fuel, the ache in your legs. That is what human distance is. It is a thing you can wrap yourself around, a length that fits inside the imagination without tearing it. Your whole life, every distance you have ever crossed, has been that kind of distance. The farthest human beings have ever travelled from home is the moon, and even that, as we will see tonight, barely counts as a first step. I want you to hold on to that feeling of a distance you understand, because it is about to become precious. For the next couple of hours, we're going to climb. We're going to start with a distance you know in your bones, and then we're going to take one step outward, and then another, and another, and at every step the ground is going to fall a little further away beneath us, and somewhere along the way, sooner than you expect, we're going to reach a distance your mind simply cannot hold. Not because you're not clever enough. Everyone reaches it. The human imagination has an edge, a place where the numbers stop being pictures and start being just numbers, and past that edge the universe keeps going anyway, indifferent to whether anything living can follow. This is the strange promise of tonight. I am not going to frighten you with monsters or catastrophes or the end of the world. I am going to do something quieter and, I think, stranger. I am going to walk you out into the distances that are already here, that have always been here, the empty gaps between the things you can see on any clear night, and I am going to show you exactly how far apart everything is, and I am going to do it in a particular way, a way that I think finally makes these numbers land. Because here is the problem with cosmic distance. When someone tells you a star is 4 light years away, your mind hears the word star, and it hears a number, and it files the whole thing away as far, without ever feeling it. The distance goes in one ear and vanishes. It never touches you. So we are not going to do it that way. At every step tonight, I am going to take the distance in front of us, and I am going to ask a simple, almost childish question. How long would it take to cross this? Not in some abstract unit, but in things a human body understands. How long would it take if you drove there in a car at highway speed, never stopping, never sleeping? How long would it take if you could walk it? How long would a rifle bullet take, or the fastest machine our species has ever built? And, my favourite, the one we will come back to again and again tonight, how long would it take a scream? If you opened your mouth right now and shouted across the gap, how long before the sound arrived on the other side? That last question has a trick hidden inside it, and we will get to the trick. But the question is the key that unlocks the whole night, because a scream is something you understand. You know how fast sound moves. You have heard thunder arrive late after lightning, counted the seconds, felt the delay in your chest. Sound is a human distance made audible, and when we start measuring the universe in screams, something happens that measuring it in light years never does. The numbers start to hurt. Before we take the first step, let me be honest with you about where this is going, because I think the honesty is part of the comfort. The distances we're going to meet tonight are not obstacles. They are not problems waiting for a clever engineer. They are not walls that a better rocket will one day punch through. They are something more final than that, and stranger, and by the end of the night I think you will see that the true horror of cosmic distance is not that something is stopping us from crossing it. The horror is that nothing is. There is no wall out there. There is no barrier, no locked door, no force holding us in place. We are entirely free to leave, and we cannot because the emptiness itself is enough, and the emptiness asks for nothing, forbids nothing, and cannot be broken, because there is nothing there to break. But I am getting ahead of us, and tonight is a night for going slowly. We have a long way to climb and no reason to hurry. So settle in wherever you are. Let your breathing slow down. If your eyes are already heavy, let them close, because none of this requires your eyes, only the quiet back rooms of your mind where pictures form. We are going to begin with the easiest distance in the whole sky, the one that hangs over your roof most nights, close enough to see the shadows on its face. We are going to begin with the moon, and I promise you, before we have even left it behind, the ground will have already started to fall away. There is a reason the mind works this way, and it is worth naming, because it tells you something about why tonight will be difficult. Your sense of distance was not built to measure the universe. It was built, over millions of years, to measure the things that mattered to a creature surviving on the ground, on one small world. How far to the water? How far to the trees? How far a thrown stone travels? How far a day's walk covers? How far away a moving shape becomes a danger? Those are the distances your instincts were tuned for, and they are all human distances, all of them things a body can cross in a day or a season. The universe was never part of that training. Nothing in the long shaping of your mind ever needed to picture a light year, and so nothing in your mind can. You're trying to see the ocean with an eye that was built to judge the width of a stream. That is not a flaw in you. It is the same for every human being who has ever lived, the cleverest scientists included. They do not picture these distances either. They learn to work with the numbers, to calculate with them, to trust them, but the pictures fail for them exactly as they will fail for you tonight, because the pictures are not something a human mind can make. What we can do instead is build a bridge, a handrail, a way of feeling our way toward the edge of what we cannot see, and that handrail tonight is the scream, and the car, and the walk, and light itself, because those are things you do understand, and by watching what happens to them as we climb, you can feel the shape of a distance even when you cannot picture it. So this is the method, and I want you to trust it. Every time we reach a new rung, I will hand you something familiar, and I will let it break in your hands, and the breaking is the point. The breaking is the closest a human being can come to feeling how far these things really are. Keep the scream ready. We're going to need it all the way up. Take one last look, then, at the distances you know, the room you are in, the town you live in, the farthest you have ever travelled. Hold them gently, the way you would hold something you're about to set down for a long time. Because this is the last time tonight your mind is going to feel at home. From here on we go up, and up, and up. And the first step, the small one, the easy one, is already farther than you think. Part 2. The gap to the nearest world. Look up on a clear night, and the moon looks close. That is the first lie the sky tells you. It hangs there with a face, with features you can name, close enough that people have always felt they could almost reach it. Close enough that we drew rabbits and men and faces in its shadows because it felt like a companion rather than a world. It is the nearest thing to us in all of space, our one true neighbour, and for that reason it is the perfect place to begin, because if any cosmic distance is going to feel manageable, it is this one, and it will not. Even this one will not. The moon sits, on average, about 384,000 kilometres away. That is a number, and I promised you we would not deal in bare numbers, so let me start turning it into something you can feel. Here is the first way in, and it is the one that gets most people, because it sounds like it cannot possibly be true. Take every planet in the solar system, Mercury, Venus, Mars, then the giants, Jupiter, Saturn, Uranus, Neptune, all of them, lined up side by side, edge to edge like beads on a string. Now take that whole string of worlds and lay it in the gap between the Earth and the Moon. It fits. Every planet in the solar system, All of them together would fit in the space between us and the moon, with room left over. The gap to our nearest neighbour is wide enough to swallow the entire lineup of planets and still not be full. Sit with that for a moment, because it rearranges something. The moon is not sitting just outside our window. The moon is across a gulf so wide that you could pour the whole planetary family into it and lose them in the emptiness. And this is the close one. This is the distance we are calling easy. Now let us start crossing it in the human ways and watch what happens. Light, the fastest thing that exists, the absolute speed limit of the universe, crosses the gap to the moon in about 1¼ seconds, 1 second and a little more. When astronauts on the moon spoke to controllers on Earth, there was a delay in the conversation, a pause of over a second each way, because even radio waves moving at the speed of light needed that long to make the trip. So already, at the very first step, at the nearest object in the entire sky, the fastest thing in existence takes more than a second to arrive. Hold that, because we're going to watch that 1¼ seconds grow into numbers that will not fit in a human life, and then into numbers that will not fit in the age of the universe. Now, the human speeds. Get in a car, drive at highway speed, 100 kilometers an hour, and never stop. Do not sleep, do not refuel, do not slow for anything. Just drive, straight up toward the moon. At that speed, you would arrive in about 160 days, more than 5 months of driving without a single pause to reach the nearest object in the sky. 5 months of your life, day and night, foot on the pedal, and that is the neighbour, the easy one, the close one. And now, the scream. This is where the night truly begins. If you could open your mouth and shout toward the moon, and if the sound could somehow travel the whole way at the speed sound moves through air, your scream would take about 13 days to arrive, almost 2 weeks. You would shout, and then you would wait, and the days would pass one after another, morning and night and morning again, for 13 days, and only then would the sound of your voice finally reach the surface of the moon. Think about how far away something has to be for a scream to take 2 weeks to get there. That is the nearest world. I want to stop here and take you up, just for a moment, because I think you should stand in this gap before we leave it. Imagine you are floating in the black halfway between the Earth and the moon. Behind you, the Earth is a blue and white marble, close enough to see storms turning slowly across its face. Ahead of you, the moon is a grey world, cratered and still, and between them, all around you, is the gap. Now watch as the planets begin to appear, sliding into place beside you one by one, laid across the emptiness like a bridge that does not quite reach. Here comes Mercury, small and scarred. Here is Venus, wrapped in its pale acid clouds. Here is Mars, rust-red and silent. Then Jupiter arrives, enormous. It storms wider than the Earth, and it takes up so much of the gap on its own that you feel suddenly small beside it. Saturn slides in with its rings. Then the ice giants, Uranus and Neptune, cold and blue and far. They are all here now, every planet strung across the space between you and the moon, and there is still room. The bridge of worlds does not reach the other side. That is how wide the easy gap is. That is the distance light crosses in a second, and a scream crosses in 13 days. Let the planets fade now, one by one, back to their real homes scattered across the solar system, and let the gap be empty again. Just you and the Earth behind and the moon ahead and all that nothing in between. This is the first rung of the ladder. This is the one we call close. Let me give you the planets one at a time so the picture is not just a phrase but a thing you can see. Mercury is a small world, smaller than you think, and it slides into the gap first. Then Venus, close to the size of Earth, and then a space for Earth itself, and then Mars, a little more than half the width of our world. Already these four together have barely started across the gap. 4 rocky worlds, and still most of the distance to the moon lies ahead. Then come the giants, and they eat the distance quickly. Jupiter is enormous, 11 times the width of the Earth, and Saturn nearly as large, and then Uranus and Neptune, each about 4 times the Earth's width. Line all 8 of them up, edge to edge, and they stretch across the gap to the moon, and still leave a margin of empty space at the end. Every world our sun holds, strung together, does not quite reach across the nearest gap in the sky. Now think again about that pause in the Apollo conversations, because it is a real recording you can listen to, and it is the sound of distance made audible. When a controller on Earth spoke to an astronaut on the moon, the words travelled up at the speed of light, took a little over a second to arrive, and then the reply took a little over a second to come back, so that every exchange carried a gap of more than 2 seconds of silence built into it, a silence made of pure distance. The timelight needs to make the round trip. You can hear it. You can hear the emptiness in the pauses. That is the nearest world, the easy one, and even our voices, moving at the ultimate speed, arrived late. And hold this, because it frames everything else tonight. 24 human beings have travelled to the moon, and 12 have walked upon it, and that is the entire list in all of history of people who have gone even this far. Everyone else who has ever lived, something like 100 billion human beings across all of time, spent their whole existence closer to home than that 13-day scream. The moon is the far edge of the entire human story. And on our ladder tonight, it is the first small step, the one we are calling easy, already too far for a body to cross and already the farthest we have ever gone. There is a unit hiding in all of this that is worth naming, because it will help you climb. When light takes a certain time to cross a distance, we can simply use that time as the distance itself. The moon is a little more than 1 light second away, meaning light takes just over a second to cross the gap. The sun is about 8 light minutes away, and once you start thinking this way, the universe rearranges itself into a map of times rather than lengths, and the map is honest in a way that kilometers are not, because it tells you immediately how out of reach a thing is. A light second is close, a light minute is far, a light year, as we will see, is a gulf, and a thing measured in millions of light years is a place you can only ever see, never touch. The moon, at 1 light second, is the nearest thing on that whole map, and even it, on the human scale of screams and cars, is already months and weeks away. Hold the emptiness of the Earth to moon gap once more before we leave it, because we filled it with planets to feel its width, but its truth is that it is empty. On the real journey, once you leave the Earth behind, there is nothing between you and the moon but 250,000 miles of vacuum. No air, no dust to speak of, no halfway station, nothing but the dark and the slowly growing grey disk ahead. The Apollo crews describe the strangeness of it, the Earth shrinking behind, the moon swelling ahead, and in between 3 days of falling through pure emptiness. That emptiness, the real content of even the nearest gap, is the thing we will meet at every scale tonight. Always wider, always emptier, until the emptiness is nearly all there is. Here is what I need you to carry upward from this first step. The moon is the farthest any human being has ever gone. 24 people have travelled to it, and 12 have walked on it, and that is the entire list of human beings who have ever left the immediate neighbourhood of the Earth. Every other person who has ever lived, every one of the roughly 100 billion humans in all of history, spent their whole existence closer to home than that 13-day scream. The moon is the edge of everything we have ever done. And on the ladder we are climbing tonight, it is not the first floor. It is barely the bottom step. Because now we turn away from the moon, and we look toward the thing that gives us our days, the star at the centre of it all, and the distance is about to stop being measured in days and start being measured in lifetimes. Part 3. The star you have never truly seen. The sun is the most familiar thing in your entire life, and you have never once seen it as it actually is. That is not a riddle. It is a fact about distance, and it is the doorway into this next step because the sun is so far away that by the time its light reaches your eyes, the news it carries is already old. Let me give you the distance first, and then let us do to it what we did to the moon. The sun sits about 150 million kilometers away. Astronomers use that distance so often that they gave it its own name. They call it 1 astronomical unit, and they use it as a ruler to measure the whole solar system. When they say Jupiter is 5 astronomical units out, or Neptune is 30, they mean 5 or 30 times the distance from the Earth to the Sun. So this distance, this 150 million kilometers, is the basic yardstick of our entire cosmic neighborhood. It is the meter stick of the solar system. Remember that, because of what is about to happen to it. Light leaves the surface of the Sun and travels to your eye in about 8 minutes and 20 seconds. That is the famous number, and it is worth feeling rather than just knowing. It means that if the sun went out right now, this instant, you would not know for 8 minutes and 20 seconds. You would sit in what felt like sunlight, warm and bright, while the star that made it was already dark, and the last light it ever sent would keep arriving for over 8 minutes before the sky finally went black. The sunlight on your skin at this moment left the sun before you started listening to this sentence. You are not seeing the sun. You're seeing where the sun was 8 minutes ago. You never see it as it is. None of us ever have. Now let us cross it in the human ways and watch the ruler of the solar system turn into something monstrous. Get back in the car, highway speed, 100 kilometers an hour, no stops, the same relentless drive we used to reach the moon. To the moon it took 5 months. To the sun, at the same speed, it would take about 170 years. 170 years of driving without ever stopping. You could not do it in a lifetime. You could not do it in 2 lifetimes. A person born at the start of that drive would live their whole life, grow old, and die, and their child would live and grow old and die, and somewhere in the 3rd generation, the car would finally arrive at the sun. The basic ruler of the solar system, the distance astronomers use as their smallest convenient unit, is longer than any human life at any speed a human body can produce, and the scream. To the moon, a scream took 13 days. To the sun, a scream would take about 14 years. Shout toward the sun, and a newborn child would be starting school by the time the sound arrived. 14 years of silence between the cry and its landing. Even a rifle bullet moving faster than sound would need almost 5 years to cross the gap to the sun. 5 years for a bullet to reach the nearest star to Earth. Because that is what the sun is when you strip away its familiarity. It is a star. It is the nearest star to us by an enormous margin, and it is already this far. I keep coming back to the fastest thing we have ever built, and I will keep coming back to it all night, because it is the honest measure of what we can actually do, as opposed to what we can imagine. That machine is a space probe called Voyager, and we will spend real time with it soon, but for now just hold this. Voyager moves at about 17 kilometers every second, not every hour, every second. It is the fastest departing object our species has ever made, unimaginably faster than any car or bullet. And even Voyager, at that blistering speed, would take about 100 days to cross a single astronomical unit, 3 months and more for our fastest machine to cross the smallest ruler of the solar system one time. Let me remind you where we are on the ladder, because it is easy to lose the thread among the numbers, and the thread is the whole point. We started at the moon, the nearest world, a 13-day scream away. We have taken exactly 1 step outward, to the sun, and the scream has already grown from 13 days to 14 years. 1 step. That is what this ladder does. Each rung is not a little higher than the last. Each rung is so much higher that the last one starts to look like it was standing still, and we have barely begun. There is a quiet thing I want to add here, in the space before we climb again, because the sun gives us a chance to feel something gentle amid the enormity. Every warm day you have ever felt, every sunrise, every long golden afternoon, arrived across 150 million kilometers of perfect emptiness. The warmth on your face is the end of a journey that light began 8 minutes earlier, crossing a gap so wide that a scream would take 14 years to follow it. The sun does not feel far away. It feels like the most present thing there is, pouring its light over everything you have ever done, and it is farther than any human could travel in a lifetime of trying. That is the strange doubleness of cosmic distance, the thing we will meet again and again tonight. The far can feel near, the unreachable can warm your skin, the distance is real and enormous and completely silent about how enormous it is. And here is a thought that grows out of that 8-minute delay, one that quietly rearranges the whole sky. If you never see the sun as it is, only as it was 8 minutes ago, then the same is true far more severely of every other star. Every star you have ever seen is old news. When you look up at night and see a star that is, say, 400 years of light away, you are not seeing it as it is. You are seeing light that left it 400 years ago, when your ancestors were living lives you cannot imagine, and the star may have changed utterly since, may have flared, may have dimmed, may in some cases no longer exist at all. The night sky is not a picture of the universe now. It is a collage of 1,000 different pasts, each star showing you a different moment in history, all of them arriving together on your eye tonight and pretending to be the present. You have never once seen the sky as it is. No one ever has. We see only where things were, and the farther away they are, the farther into the past we are looking. Let me finish crossing the gap to the sun in the human ways, so the ruler is fully broken before we leave it. We tried the car, 170 years. We tried the scream, 14 years. Try a jet, a fast passenger aircraft moving at 900 kilometers an hour, far faster than any car. At that speed, the flight to the sun would take about 19 years. nearly 2 decades in the air without landing at jet speed to reach the nearest star, and a rifle bullet, one of the fastest things a human hand can launch, moving at the speed of a bullet, would need almost 5 years to arrive. 5 years for a bullet to reach the sun. There is something almost humble about the astronomical unit when you hold it this way. Astronomers reach for it because it is convenient, because it is small, because everything else in the solar system is so much larger that they needed a modest little ruler to keep the numbers manageable. And this modest little ruler, the smallest convenient unit in the whole science of the cosmos, is already longer than every human life ever lived, at every speed a human body has ever produced. That is the humbling truth waiting one single step out from home. The smallest ruler we use is already too long to walk. Hold the sun for one more moment as what it truly is, a star, the nearest one, a 14-year scream away, its light already 8 minutes old before it touches you. Because now we are going to leave it behind. We are going to travel outward, past the planets, out toward the cold edge where the sun's reach finally gives way to open space. And out there, at what you might think is the edge of the solar system, we are going to discover that the edge is not the edge at all, and that a word you thought belonged to the stars actually begins right here, in our own backyard. Part 4. Out past the planets to the edge of the wind. Leave the sun behind now and turn your face outward, toward the cold. We are going to travel away from the light, past the worlds you know, out to the place where the sun finally loses its grip. And the first thing you need to understand is that the solar system is almost entirely empty. The planets are not crowded together. They're scattered across enormous gaps, tiny islands of rock and gas separated by oceans of nothing, and the farther we go, the wider those oceans become. Start with the journey to Neptune, the outermost of the major planets, the last of the great worlds. Neptune orbits at about 30 astronomical units from the Sun. Remember what an astronomical unit is now. It is the distance we just crossed, the one that takes a car 170 years and a scream 14 years. Neptune is 30 of those laid end to end. Light from the Sun, which reached your eye in 8 minutes, takes about 4 hours to crawl all the way out to Neptune. 4 hours for light. The same light that crosses the gap to the Moon in a single second needs 4 hours to reach the outermost planet. We have actually made this trip, or something close to it, and this is where the fastest machine we have ever built stops being a thought experiment and becomes a real thing with a real history. In the 1970s, we launched 2 space probes called Voyager, and one of them, Voyager 2, flew outward past the giant planets, and it took that probe 12 years to reach Neptune. 12 years of flight at 17 kilometers every second just to cross our own solar system to its outermost major world. A child born on the day of that launch was finishing school by the time the probe sailed past Neptune and sent back the first close photographs of that blue and distant world. 12 years to reach the edge of the planets, moving faster than anything human hands had ever built. But Neptune is not the edge of the Sun's reach. It is only the edge of the planets. Keep going outward, past Neptune, and eventually you come to a boundary called the heliopause, and this is a genuinely strange and important place, so let me tell you what it is. The Sun is not just a ball of light. It is constantly blowing outward a wind of particles, a stream of charged matter racing away from its surface in every direction, filling the space around it, pushing outward against the thin gas that drifts between the stars. That solar wind blows and blows, farther than all the planets, until finally at some enormous distance it runs out of push. It meets the pressure of interstellar space, and it can go no further. That meeting place, that shore where the Sun's wind finally stops, is the heliopause. It sits at roughly 120 astronomical units from the Sun. 120 of those rulers, each one a 14-year scream long. Light takes about 17 hours to reach the heliopause. Not seconds, not minutes. 17 hours for light. And Voyager 1, the faster of the 2 probes, the one that flew a more direct path outward, took about 35 years to get there. 35 years of continuous flight, launched in the 1970s, and it did not cross out through that boundary until the 2010s, most of a human working life spent in flight to reach the place where the Sun's wind finally gives out. And when Voyager crossed that boundary, it became, in a real sense, the first human-made object to leave the bubble of the Sun's influence and enter the space between the stars. Now here is the twist, the thing that makes this step matter, the reason the edge of the wind is not the edge of the story. The heliopause is where the Sun's wind stops. It is not where the sun's reach stops, because the sun does not hold its family together with wind. It holds them together with gravity, and gravity reaches far farther than any wind. The sun's gravity keeps its grip on objects far, far beyond the heliopause, out into a region so distant and so enormous that it makes everything we have discussed so far look like the front step of a house whose grounds stretch to the horizon. Let me stay in this cold place for a moment before we take the next step, because I think it deserves a pause. Out here, past the planets, past the wind's edge, the sun is no longer a disk. It is a brilliant point, the brightest star in a black sky, but a point nonetheless, no longer something that warms you, just the brightest of the many lights scattered around you. If you were standing on some frozen rock out here, you could block the sun out with your thumb. The thing that has poured warmth over every moment of your life, the star that took a car 170 years to reach, is now just a bright spark you could cover with the tip of your finger. And you're not even at the edge of its family yet. You're only at the edge of its breath. The 2 Voyager probes were not simply flung outward at random. They were launched to take advantage of a rare arrangement of the outer planets, an alignment that let a single spacecraft swing past one giant world after another, using the gravity of each to fling itself onward to the next. A cosmic game of catch that would not come around again for more than a century. Voyager 2 rode that arrangement past Jupiter, then Saturn, then Uranus, then Neptune, the only spacecraft in history to visit all 4 giant worlds, and at each one it sent back the first close portraits humanity had ever seen. It showed us the storms of Jupiter, the fine structure of Saturn's rings, the tilted strangeness of Uranus, the dark blue of Neptune with its white streaking clouds. 12 years of flight to gather those images, and each world was only a brief flyby, a few hours of close approach after years of crossing the emptiness in between. That emptiness is the thing the missions truly reveal. Between each giant planet lay years of nothing, the probe coasting through dark and silent space with the sun shrinking behind it, and the gaps between the worlds are the real content of the solar system. The solar wind that fills those gaps, the stream of particles the sun blows outward, races along at hundreds of kilometers every second, far faster than any rocket, and even that wind takes the better part of a year to reach the outer planets, and many more years to reach its own far shore. When you measure the solar system by the wind that fills it, it is enormous. When you measure it by the worlds scattered through it, it is almost entirely empty. There is one image from that journey I have to give you, because it belongs here. As Voyager 1 sailed outward, past the planets, we turned its camera around, back toward home, and let it take one last photograph. And in that photograph, the Earth appears as a single point of light, less than a single pixel, a pale dot suspended in a beam of scattered sunlight, so small and so faint that you could miss it entirely. Everything that has ever happened to our species happened on that dot. Every person you have ever known, every life, every war, every love, all of it on a mote too small to see, photographed from the edge of our own planetary neighbourhood, a place we reached only after 12 years of the fastest flight we could manage. And that edge, remember, is not the edge. We are still, even here, far inside the sun's true reach. Feel how far we have come, and feel how little it is. We have travelled out past every planet, out to the boundary of the solar wind, a journey that took our fastest machine 35 years, and we're about to discover that we have not even crossed a third of the way to the true edge of the sun's domain. The gaps are widening under us. The ocean of nothing is getting farther, and the word that is coming next, the word for the distance ahead, is a word you thought you understood, a word you thought belonged out among the stars. It does not. It begins right here, in what we have the nerve to call our own backyard. Part 5. The light year in your own backyard. There is a phrase we use for the distances between stars, and you have heard it your whole life. The light year. It sounds like the ultimate unit of far, the measure we reserve for the space between one sun and another, a word so large it belongs only to the emptiness between stars. And tonight I have to tell you something that genuinely unsettles most people when they first truly grasp it. The light year does not begin out among the stars. It begins inside our own solar system. Our home is so large that we run out of smaller words and have to start measuring the sun's own backyard in light years. Here is how that happens. Beyond the heliopause, beyond the wind's edge, the sun's gravity keeps reaching, and out in that reach there is a shell of icy objects, countless frozen leftovers from the birth of the solar system, drifting in slow orbits around the distant sun. This shell is called the Oort cloud, and it is where the long-period comets come from, the ones that fall inward toward the sun once every few thousand or few million years, blaze briefly in our skies, and then vanish back into the dark for ages. The Oort cloud is the true outer boundary of the sun's family, the last place where objects still, however faintly, belong to our sun rather than to the emptiness between stars. And the Oort cloud is enormous beyond any easy telling. Its outer edge reaches to something like 100,000 astronomical units from the sun. Stop and let that number turn over. 100,000 of those rulers, each one a distance that takes a car 170 years. And when you convert 100,000 astronomical units into the language of the stars, it comes to roughly 1.5 light years. A light year and a half still inside the sun's own gravitational reach. The word we reserved for the space between stars turns out to describe the far suburbs of our own solar system. Cross it in the human ways, and the numbers stop being survivable. Light, which took 17 hours to reach the heliopause, takes about a year and a half to reach the outer edge of the Oort cloud. Light itself, spending a year and a half just to cross our own solar system's outer shell. And Voyager, our fastest machine, the probe that needed 35 years to reach the wind's edge, would need something like 28 to 30,000 years merely to cross the Oort cloud. Not to reach another star, just to pass through the outermost part of our own solar system. 30,000 years. That is longer than all of recorded human history several times over, spent flying at 17 kilometers a second, just to get out of our own house. I want you to really feel the strangeness of this, because it reorders your sense of where you live. You probably carry, somewhere in your mind, a picture of the solar system as a tidy little arrangement, the sun in the middle, the planets circling around, a neat diagram that fits on a page. That diagram is a lie of scale. The planets are a tiny cluster huddled close to the sun, and around them, reaching out more than a third of the way to the nearest other star, is an almost unimaginable halo of dark, drifting ice, so wide that light needs a year and a half to cross it. The solar system is not a tidy diagram. It is mostly this. It is mostly the enormous dark shell that no diagram ever shows you, because no page is large enough to hold it at true scale. And here is the part that starts to press on the mind. The nearest star to our sun, the very next star, is only about 4.25 light years away. Our own Oort cloud reaches out a light year and a half, which means the sun's own outer shell of comets extends more than a third of the way to the nearest neighbouring star. Our house does not have a clean edge. It does not stop at a wall. It simply thins out, fading gradually into the emptiness, until at some point the comets that still, barely, belong to our sun give way to the comets that might, barely, belong to the next one. There may be regions out there where the outer reaches of our solar system and the outer reaches of the nearest star system effectively overlap, two enormous halos of drifting ice, fading into each other across the dark with no clear line between them at all. Let me slow down here, in this immense dim shell, because we have reached a threshold, and I want us to cross it consciously. Everything up to this point, the moon, the sun, the planets, the heliopause, all of it has been home. All of it has been the sun's own domain, the neighbourhood, the backyard. We have spent the whole climb so far without ever leaving the property, and it has already defeated us. Our fastest machine would need 30,000 years just to reach the property line. A scream, out here at the edge of the Oort cloud, would take well over 1,000,000 years to arrive, and we still have not gone anywhere. We have not visited a single other star. We have not left home. We have never seen the Oort cloud directly. It is too far and too dark, its objects too small and too cold to catch in any telescope across that immensity. And yet we know it is there, and the way we know is one of the quiet triumphs of patient observation. Every so often, a comet falls inward from the outer dark on an enormous orbit, blazes around the sun, and swings back out again, and when astronomers trace the paths of these long-period comets backward, they find that they come from every direction, not just from the flat plane where the planets orbit, but from above and below and all around, as if the solar system were wrapped in an unseen sphere from which these visitors occasionally drop. That sphere is the Oort cloud, inferred from the comets it sends us, a shell of icy bodies surrounding the whole solar system in every direction, so distant that a single orbit for one of its members can take millions of years. Think about what that means for the shape of home. The planets orbit in a flat disk, a thin plate spinning around the sun, and that plate is what every diagram shows you. But wrapped around that plate, enclosing it completely, is this enormous spherical shell of ice, reaching out more than a light year in every direction, above and below and around. Our solar system is not a flat little pinwheel. It is a small bright disk at the centre of an enormous dark sphere, and the sphere is so wide that light takes a year and a half to cross from one side of it to the other. Almost all of that sphere has never been seen and never will be, a region of our own solar system larger than anything we could ever map, populated by uncounted frozen worlds drifting in a cold so complete it has not changed since the sun was born. And this is the part that sets up everything ahead. The outer edge of that shell reaches more than a third of the way to the nearest star. Our home does not end at a clean boundary and then give way to interstellar space. It simply fades, thinning out with distance, the sun's grip weakening, the ice growing sparser, until at some unmarked point the last object that still belongs to our sun gives way to the first object that belongs to no one, or to the next star. There is no fence, there is no line. There is only the slow fading of home into the emptiness between the stars, and we are about to step across that emptiness, and it is wider than everything we have crossed so far combined. That is the thing I need you to carry up to the next rung. Everything so far was the easy part. Everything so far was inside our own solar system, and it was already beyond us. Now we're going to step across the true gap, the first real gap, the emptiness between our sun and the nearest other star. And to prepare for it, I want to take you out to the very edge of everything we have called home, to the last cold rock at the outer limit of the sun's reach, and I want us to do something there. I want us to stand at the edge of our own solar system, turn toward the nearest star and scream. Part 6. The Scream at the Edge of Everything. Come with me out to the edge, not in numbers this time, but in your body. Let the calculations rest for a few minutes, and let us simply go and stand at the outer shore of the sun's domain, and look out at what comes next, and try to feel it the way you would feel a cliff edge in the dark. You're standing on a small frozen world at the outer edge of the Oort cloud, a chunk of ancient ice that has drifted here, faintly bound to the sun since before the earth had oceans. Under your feet the ground is old beyond old, black ice and frozen gas, hard as granite in the terrible cold. There is no air, there is no sound. There has never been sound here, not once. In all the billions of years this rock has drifted in the dark. Above you and around you the sky is not like any sky you have known. It is utterly black, and it is full of stars, and the stars do not twinkle, because there is no air to make them shimmer. They simply hang there, hard and steady and cold, points of light that have not moved in a human lifetime. Turn around and find the sun. It is there, behind you, and you will know it because it is the brightest star in the sky. But that is all it is now. A star. The brightest one, yes, but only a point, a spark of white light with no disk, no warmth, no size. You could hold up your hand and cover it with the tip of one finger. Everything you have ever loved, everyone who has ever lived, the whole of human history, all of it is happening on a mote of dust circling that single bright point you could blot out with a fingertip. From here, home is just another star. Now turn back around, away from the sun, and face the darkness ahead. Somewhere out there, in the direction you are facing, is the nearest star. Not the sun, the next one. From here it is one of the points of light in front of you, not obviously different from the others, not obviously special, just another cold, unblinking spark in the black, and between you and it, there is nothing. Not thin gas, not scattered dust, but for all human purposes nothing at all, a gap so wide and so empty that the distances we have been discussing all night were only the run-up to this. And now, I want you to do the thing we came here to do. I want you to open your mouth and face that nearest star and scream. Scream as loud as you can, with everything in your lungs, the way you would scream if you needed the whole universe to hear you. Nothing happens. There is no air. The sound does not travel. It does not even begin to travel. Your scream, the loudest sound you can make, dies in your own throat, because out here in the emptiness between the stars there is no medium to carry it, nothing to press the sound forward, no way for your voice to move even 1 single meter into that dark. This is the first horror of the gap, and it is worth sitting in. Space does not carry a scream at all. The very question we have been asking all night, how long would a scream take to cross this, has a cruel answer out here. It would never even start. But let us grant the impossible, as we have all night. Let us pretend the sound could travel, could somehow ride across that emptiness at the speed sound moves through air. How long, then, would your scream take to reach the nearest star? The answer is about 3,700,000 years. 3.5 million years and more. You would scream, and if that sound could travel, it would set out across the dark, and it would still be travelling when everything you have ever known had turned to dust. It would still be travelling after the pyramids had eroded to sand, after the continents had rearranged themselves, after your species had changed beyond recognition or vanished entirely. 3.5 million years for a scream to cross the first gap, the smallest gap, the gap to the very nearest star. Stand in that for a moment. Stand on the cold rock, at the edge of everything we call home, having screamed into a silence that swallowed the sound before it began, knowing that even if it could travel, it would arrive so far in the future that no trace of you would remain to have sent it. That is the distance to the nearest star. That is the next step. And I brought you here to feel it with your body before we go back to the numbers, because the numbers alone will lie to you. They will let you file it away as far. But you have stood here now. You have opened your mouth at the edge of the sun's reach and heard nothing come out, and looked at the nearest star hanging cold and unbothered in the black, and some part of you now knows, in a way that cannot be unknown, how alone a thing can be simply by being far. Feel the cold first, because the cold is the truest thing about this place. This far from the sun, there is almost no warmth at all, only the faint memory of it, and the surface under you is colder than anything on Earth has ever been. Cold enough that gases you breathe every day would lie frozen solid as rock. The ice beneath your feet has never melted, not once in the entire history of the solar system. It formed when the sun was young, and it has drifted out here in the dark ever since, untouched, unwarmed, unchanged, older than the oceans, older than the continents, older than life. You're standing on something that has been waiting in the cold since before the earth had a face, and feel the silence, because it is not the silence you know. On Earth, even the quietest night has sound in it, the faint stir of air, the small movements of a living world. Here there is nothing, because there is nothing to carry sound, no air, no medium, no way for a vibration to travel. It is not that it is quiet here, it is that sound itself cannot exist here. The silence is total and it is structural, built into the emptiness, and it has never once been broken. In all the billions of years this rock has drifted by any sound at all. You're standing in a silence older than the earth, a silence that has never had a single sound in it, and your scream cannot break it, because your scream needs air to be a sound at all, and there is no air, and there never was. That is why the scream dies in your throat. Not because it is too far to travel, because it cannot begin. The emptiness does not even give your voice the dignity of a slow journey. It simply refuses to carry it at all, and the loudest sound you can make ends at your own lips, unheard, unspread, unborn. And even the mercy of the thought experiment, even granting the impossible and letting the sound travel at the speed sound moves through air, buys you only a horror of a different size, 3.5 million years of travel toward a star that will not have moved, across a gap that does not care, a cry that would still be crossing the dark long after the last trace of you had gone. Stand in it. This is the edge of home, and it is already further from the next thing than the mind can hold. Look up now, from the cold rock, at the sky you would actually see out here, because it is unlike any sky on Earth and it prepares you for what is coming. The stars do not twinkle, because there is no air to disturb their light, and so they hang perfectly still and hard, more numerous and more steady than any sky you have known, a field of unwavering points in a black so complete it has depth to it. And somewhere among those points is the nearest star, the one you screamed toward, indistinguishable to your eye from the others, no larger, no brighter in any way that would mark it as the closest thing in all the heavens beyond your own dimmed sun. That is the cruelty of the view. The nearest neighbour we have does not even stand out. It is just one more cold point among thousands, and it is 4.25 light years away, and it is the near one. Stay one more moment in the silence because I want you to carry it upward. Everything we have felt so far, the 13-day scream to the moon, the 14-year scream to the sun, was still inside the warmth and nearness of home. Here, at the edge of the Oort cloud, we have finally reached the true dark, the place where home ends and the between begins, and the first thing the true dark does is take away your voice. It will not carry a sound. It will not carry you. It offers no resistance and no help, only distance, and more distance, in every direction, and the nearest other shore 3.5 million years away by the measure of a scream that cannot even start. This is the threshold. Beyond it lies everything we have not yet dared to climb. Let the frozen rock fade now. Let the cold ease. Come back to your warm room, your blanket, your quiet breathing. But bring the feeling with you, because we are about to give that feeling a name and a number, and we are going to discover that the nearest star, the one you just screamed toward, is closer than almost anything else in the universe, and it is still so far that our fastest machine, given more time than our species has existed, would not arrive. Part 7. The nearest star is already too far. The nearest star to our Sun is called Proxima Centauri, and its name means, appropriately, the nearest. It is a small, dim, red star, far cooler and fainter than our Sun, and it sits about 4.25 light-years away. That is the closest any other star comes to us. Out of all the hundreds of billions of stars in our galaxy, this one is the very nearest, the one at the front of the line, and I want to spend real time here, because this single distance, the smallest gap between our Sun and any other, is the one that quietly ends most of our dreams. 4.25 light-years. Let me pour that into numbers you can hold, the way we have all night. In kilometers it comes out to about 40 trillion. 40 trillion kilometers to the nearest star. But that number is too large to feel, so let me give it to you a different way, in terms of the ruler we have been using. The nearest star is about 268,000 astronomical units away. Remember the astronomical unit, the distance to the Sun, the one that takes a car 170 years to cross. The nearest star is 268,000 of those. Not 268, 268,000. The gap to the nearest star is more than 250,000 times the distance to our own Sun. Cross it in the human ways, and every method breaks. Light, which crossed to the Moon in a second and to the Sun in 8 minutes, takes 4.25 years to reach Proxima. That is the fast way. That is the impossible speed limit of the universe, and it still takes over 4 years. The scream we sent from the edge of the Oort cloud, if it could travel, takes about 3.5 million years, and our fastest machine, Voyager, moving at 17 kilometers every second, would need roughly 75,000 years to cross the gap to the nearest star, if it were even pointed that way, which it is not. But I have saved the number that truly lands it, and here it is. Voyager has been flying for about half a century now. In that time, at the fastest speed our species has ever achieved, it has crossed a certain fraction of the distance to the nearest star. That fraction is about 6/100ths of 1%, not 6%, 6/100ths of 1%, 0.06%. After 50 years of flight, at 17 kilometers a second, our fastest object has covered about 6/100ths of 1% of the way to the very nearest star, and more than 99.9% of that first small gap still lies ahead of it. If Voyager kept flying straight and true toward Proxima, it would arrive in roughly 75,000 years. Our whole species is only a few 100,000 years old. We would need to keep a machine flying for a span comparable to the entire existence of humanity so far, just to reach the closest star to our own. Let me give you one more way to feel this, because I think it is the one that stays with people, and it is worth building carefully. Let us shrink the whole thing down to a size you can walk through. Take the Sun and shrink it to the size of a basketball, something you could hold in 2 hands. At that scale, how far away is the Earth? The Earth becomes a peppercorn, a tiny grain sitting about 26 meters from the basketball, across a large room or a small yard. That is the Earth to Sun distance shrunk down. Now where is Neptune, the outermost major planet at this same scale? Neptune is another small grain, about 770 meters away, most of a kilometer from the basketball. Already the model is spreading out across a whole neighborhood, a basketball here and a few tiny grains scattered across most of a kilometer, and nothing in between but empty air. And now the question. At this same scale, with the Sun as a basketball you could hold, where is the nearest star, Proxima? Where is the next basketball? It is about 6,900 kilometers away, nearly 7,000 kilometers. If the sun is a basketball in one city, the nearest star is another basketball on the far side of a continent, thousands of kilometers away, with nothing in between but emptiness. 2 basketballs, a continent apart, and between them, in all that space, essentially nothing. That is the true density of the stars. That is how far apart the universe keeps its suns. Not close, not crowded, but scattered so thinly that the nearest one shrunk to a basketball sits a continent away from ours. I said at the start of the night that the far can feel near, and here that doubleness returns in a way that presses on the mind. Proxima Centauri is the nearest star. In all the enormous catalogue of the galaxy, it is the closest neighbour we have, the friendliest number, the least of all the interstellar distances, and it is already, for all human purposes, unreachable. Not difficult, not expensive, unreachable in the way that matters, because to send anything there and have it arrive would take longer than our species has so far existed, and we would have to keep it running and keep ourselves running across that entire span. The nearest star is the easy one, the close one, and it is beyond us. Everything past it is worse. Everything past it is the true country of horrifying distance, and we are only now stepping into it. Let me tell you a little about Proxima itself, because it makes the distance stranger, not more familiar. Proxima Centauri is a red dwarf, a small, cool, dim star, far less than our Sun in size and warmth. The kind of star so faint that you cannot see it with your naked eye at all, despite it being the nearest one to us. It belongs to a little family of 3 stars, the Alpha Centauri system, 2 sun-like stars orbiting each other, and Proxima drifting along with them, and around Proxima there is at least one planet, a world roughly the size of the Earth, orbiting in the zone where liquid water could in principle exist. So the nearest star has a nearby world, an Earth-sized world, close enough to its star for water. It is, in a sense, the most tempting destination imaginable, the nearest possible shore, the closest thing to a next step our galaxy offers us. And it is 4¼ light-years away, and everything we have said tonight applies. The most tempting destination in the universe is already past the edge of what we can reach. Let me walk you a little further into the basketball model, because the waypoints matter. With the Sun shrunk to a basketball, we said the Earth is a peppercorn 26 meters away, and Neptune a grain 700 meters out. Where, at that scale, is Voyager, our fastest machine, after half a century of flight? It has crawled a little more than a kilometre from the basketball, 1 kilometre in 50 years, at the fastest speed we have ever achieved, in a model where the nearest star is 7,000 kilometres away. To reach that next basketball, Voyager would have to keep crawling, at that same pace, for another 75,000 years. Set the whole thing in your mind if you can. A basketball, and a kilometre away a tiny probe still crawling outward, and 7,000 kilometres beyond that, across a whole continent of emptiness, the next basketball, which we will never touch. And remember, Proxima is the nearest. It is the least of the interstellar distances, the smallest gap between our Sun and any other star in the entire galaxy of hundreds of billions. Every other star is further. Most are far, far further. The gap we just failed to cross, the one that broke light itself into a 4-year crawl and reduced our fastest machine to 0.06%, is the friendliest gap the galaxy has to offer. There is no shorter interstellar jump anywhere near us. This is as close as another sun ever comes, and it is already the end of the road for anything we could ever build and survive to see arrive. Carry this up to the next rung. We have crossed, in our imagination, the first real gap, the smallest gap between stars, and it broke every tool we have. And now I want to pause the climb, just for a little while, because before we go further out, before the numbers get larger still, I need to talk to you about what this distance actually is, not how big it is, what it is. Because there is something about the nature of these gaps that most people never quite put into words, and once you see it, the horror of cosmic distance changes shape. It stops being about size, and it becomes about something much stranger and much more final. Part 8. The Cage Made of Nothing. I want to stop climbing for a while and ask a simple question that I think is the true centre of this whole night. Why can we not go? We have seen that the nearest star is unimaginably far, but far by itself is not the same as impossible. Human beings have crossed distances that seemed impossible before. We crossed oceans that our ancestors thought had no far shore. We reached a pole that killed the people who first tried for it. We stood on the moon. So what is different about the gap to the stars? What exactly is stopping us? And the answer, when you finally look at it clearly, is the strangest part of the whole story. Nothing is stopping us. There is no wall out there. There is no barrier at the edge of the solar system. No force field. No locked door. No dragon guarding the dark. Space does not push back against us. It does not forbid us to leave. If you built a ship and pointed it at Proxima Centauri and fired the engines, nothing in the universe would rise up to stop you. You would simply go and go and go, and the emptiness would part around you and close behind you, offering no resistance, raising no objection, and you would still never arrive, because there is simply too much of it. The distance itself is the only thing holding us in place, and the distance is made of nothing at all. Think about what a strange kind of prison that is. Every cage you have ever seen is made of something. Bars, walls, locks, guards, chains, all of them are made of matter, and all of them can, in principle, be broken. A wall can be climbed or knocked down. A lock can be picked. A guard can be evaded. Every barrier ever built has a weakness, because a barrier is a thing, and things can be overcome. But the emptiness between the stars is not a thing. There is nothing to break, nothing to climb, nothing to pick, nothing to fight. There is only more distance, and beyond it more distance, and beyond that more still, in every direction, farther than any engine can carry us in any span of time we could survive. It is a cage with no bars, and that is precisely why it is the most perfect cage imaginable. You cannot break out of nothing. You can only try to cross it and fail and drift and fall short forever. This is the thing I most wanted to show you tonight, and I told you at the very beginning that this was where we were going. The horror of cosmic distance is not that something out there is stopping us. The horror is that nothing is. We are not imprisoned. We are simply too far from everything else, held in place not by force but by sheer emptiness, and that is worse than any wall, because a wall gives you something to push against. A wall gives you hope, the hope that one day you might be strong enough or clever enough to bring it down. The emptiness gives you nothing to hope against. It just extends, silent and unresisting and endless, and it keeps us exactly where we are, on this one small world, more completely than any chain ever could. I said early tonight, when we were still close to home, that there is no wall, and I meant it then as a small reassurance, a way of saying nothing is against us. Now, I need you to hear the same words differently. There is no wall. That is not the good news. That is the whole tragedy spoken in 4 words. Because if there were a wall, we could dream of breaking it. Since there is not, there is nothing to break, and we are left free, entirely free and entirely unable to go, and those two facts sit together in a way the mind does not want to hold. Let me make it personal, because I think it lives closer to you than it seems. You have felt a smaller version of this. You have stood in an airport or a doorway or a driveway watching someone leave and known that nothing physical was stopping you from calling them back, from crossing the space between you, from closing the distance, and yet the distance held anyway, because some distances are not meant to be crossed, and the emptiness in them is real even when it is only a few meters of ordinary air. The universe has taken that feeling, that particular ache of a distance that nothing forbids and nothing lets you cross, and it has written it across the entire sky, in gaps so wide that light itself grows old inside them. Every star you can see is something you are free to go to and can never reach. The whole night sky is a field of open doors that lead nowhere you can walk. And here is the part that turns this from despair towards something quieter and almost gentle, because I do not want to leave you only in the cold. The same emptiness that holds us in place is also what gives us a sky to look at. If the stars were close enough to reach, they would be close enough to burn us, close enough to tear our world with their gravity, close enough that the calm and stable sky we evolved under would never have existed at all. The distances that trap us are the same distances that let us be here safely, on a quiet world, far from the violence of other suns, with a clear dark sky to wonder at. The cage and the sanctuary are the same thing. The emptiness that will not let us leave is the emptiness that let us begin. That is not a comfort exactly, but it is a truth worth holding alongside the cold one, and on this channel we try to hold both. Consider what a barrier actually gives you, psychologically, because it is more than you might think. A wall is an enemy, and an enemy is something you can organize against. When people faced an ocean they could not cross, they did not simply despair, because the ocean was a thing, and things can be studied and beaten. They built better boats. They learned the winds and the currents. They passed the knowledge down through generations until, at last, the far shore was reached. Every barrier in human history has been like this, a thing with properties, a thing that could be understood and eventually overcome, and so every barrier has come with hope folded inside it. The hope that effort and cleverness would one day be enough. The barrier and the hope arrive together, because to name a wall is already to begin imagining its fall. The emptiness between the stars offers none of that. There is nothing to study because there is nothing there. There is no current to learn, no wind to master, no structure to find a weakness in. There is only distance, uniform and featureless and enormous, the same in every direction, offering no handhold for hope to grip. You cannot build a better boat for crossing nothing, because the problem is not that the crossing is hard. The problem is that the crossing is long, longer than any life, longer than any civilization, longer in the most extreme cases than the universe itself, and no cleverness changes the length of a thing. That is why the emptiness is a more perfect cage than any wall. It gives despair nothing to push against, and it gives hope nothing to hold. I gave you a small human version of this earlier, the doorway, the driveway, the person leaving while nothing physical stops you from calling them back. Let me give it to you once more, because it is the truest bridge I have to this feeling. You have known a distance that nothing forbids and nothing lets you cross. A person you could still call, and did not. A closeness that ended without any wall between you. Just a growing quiet, a gap that widened not because anything stopped you, but because the crossing became, somehow, more than either of you could make. That ache, the ache of a distance held open by nothing at all, is exactly the ache the universe has written across the whole sky. Every star is a door left open onto a room you can never enter. Nothing is stopping you. That is the whole of it. Nothing is stopping you and you cannot go, and there is no one to blame and no wall to break and nothing to do but look. Now let us climb again, because we have only just entered the real country of distance, and I have been honest with you that it gets worse. We have crossed the gap to the nearest star in our minds. We are going to leave the neighbourhood of nearby stars entirely now, and pull back until our whole sun and Proxima and every star you have ever seen with your naked eye all shrink into a single glowing structure, and we are going to try to cross that structure, and we are going to bring back the scream, the childish little question from the beginning of the night, and watch what it becomes. Part 9. The Scream That Outlives the Universe. Pull back now, far enough that the individual stars begin to lose themselves in the crowd. Every star you have ever seen with your naked eye, every point of light in every night sky of your whole life, belongs to a single enormous structure, a slowly turning wheel of stars called the Milky Way, our galaxy. It contains somewhere between 100 billion and 400 billion stars, our sun among them, one ordinary star lost in a throng of hundreds of billions. And it is time to ask how far it is across, and to bring back our oldest and simplest question, the scream, and let it tell us something the numbers alone cannot. The Milky Way is about 100,000 light-years across. Let me set that beside what we already know so it lands. The nearest star, Proxima, was 4¼ light-years away, and that distance was already enough to defeat us completely, already enough that our fastest machine would need 75,000 years to cross it. The galaxy is 100,000 light-years across. That is not 4 light-years, it is 100,000 of them, laid end to end. The gap that broke every tool we own, the gap to the nearest star, would have to be repeated more than 20,000 times to span the galaxy, and each of those gaps is itself so wide that a scream would take 3.5 million years to cross it. Our own sun sits far out toward the edge of this wheel, about 26,000 light-years from the centre. Just to reach the middle of our own galaxy, the bright crowded core where the stars gather thick and a giant black hole waits at the very centre, you would have to cross 26,000 light-years. Light itself, leaving our sun right now, would take 26,000 years to reach the galactic centre, and 100,000 years to cross from one edge of the galaxy to the other. Light, the fastest thing there is. The thing that crossed to the moon in a single second needs 100,000 years to cross the galaxy we live in. And now, the scream. This is the moment I have been building towards since the very beginning of the night, since we first stood beneath the moon and asked our small, almost silly question. How long would a scream take to cross the galaxy? Back at the moon, a scream took 13 days, and it seemed almost quaint, a curious little fact. To the sun it grew to 14 years. At the nearest star it became 3.5 million years. And across the galaxy, a scream, if it could somehow travel the whole way at the speed sound moves through air, would take about 87 billion years to cross the Milky Way. Sit with that number, because it does something that no distance so far has done. The universe itself is about 13.8 billion years old. 87 billion years is more than 6 times the age of the universe, which means this. If a scream had set out across our galaxy at the very moment the universe began, at the Big Bang itself, at the start of all time, it would not be even a fifth of the way across yet. It would still be travelling. It would have to travel more than 6 times the entire history of everything, from the first instant of time until now and far, far beyond, just to cross the single galaxy we happen to live in. The universe is not old enough for a scream to have crossed our galaxy even once. There has not been enough time since the beginning of time for that sound to make the trip. Let me hold you here, because I know this is a lot, and this is exactly the kind of number the mind wants to slide off of. Do not let it slide. Stay with it, gently. We began the night with a scream that took 13 days to reach the moon, and it felt almost cozy, a strange little unit of distance. That same scream, that same human sound from that same human throat, would need 87 billion years to cross our galaxy, 6 times longer than the universe has existed. The question did not change, the distance did. And watching what happened to that one simple question, as we climbed from the moon to the galaxy, is, I think, the clearest way a human mind can feel the shape of these distances, because you have carried the scream all this way, and you have felt it grow in your hands from 13 days into a span that outlasts the cosmos. There is something I want to name here, quietly, because it has been growing under everything we have said. These distances are not just large, they are large in a way that has nothing to do with us. The galaxy was not built to be crossed. The gap to the nearest star was not sized for travellers. There is no scale anywhere in what we have seen that matches a human life, or a human civilization, or even the whole lifespan of an intelligent species. The astronomical unit, the smallest convenient ruler, already outruns a lifetime. The galaxy outruns the universe when measured in the speed of a human voice. Whatever these distances are for, if they are for anything at all, they are not for us. We are a brief warm arrangement of atoms that happens to be able to measure them, and that is a strange and rare thing to be. But the distances themselves do not know we are here, and would not change by a single metre if we never had been. Let me give you a feeling for the crowd our sun belongs to, because the number of stars is itself a kind of distance. The Milky Way holds somewhere between 100 billion and 400 billion stars. Take the middle of that range and imagine trying to count them, 1 per second, without stopping. It would take you thousands of years just to count the stars in our galaxy, and every one of those stars is a sun, many with worlds of their own, and every one of them is separated from its neighbours by gaps like the one we just failed to cross, the 4-year gap, the gap that reduced our fastest machine to a crawl. The galaxy is not a crowd in any human sense. It is hundreds of billions of suns, each one alone in its own enormous pocket of emptiness, the whole structure held together not by closeness, but by the slow, patient grip of gravity reaching across the dark. At the centre of it all, 26,000 light-years from us, in the direction where the stars gather thick and bright, there is a black hole of monstrous size, millions of times the mass of our sun, around which the entire galaxy slowly turns. And we do turn. Our sun, carrying the Earth and all of us with it, is moving around that centre at enormous speed. And yet the galaxy is so large that a single orbit, one trip around, takes about 230 million years. The last time our sun was at this point in its orbit around the galaxy, the dinosaurs had not yet risen. We have not completed a single circuit of our own galaxy since creatures walked the Earth in any form we would recognize. That is one turn of the wheel we live on. That is how large the structure is that a scream cannot cross in 6 times the age of the universe. Come back to that scream one more time, because I want you to hold what has happened to it across this whole night. It began as the gentlest thing, a shout toward the moon, 13 days, almost sweet, a child's measurement of the sky, and you carried it with you, up past the sun, out past the planets, to the edge of home, across the gap to the nearest star and now across the galaxy, and it has become a span so long that time itself runs out before it finishes. 87 billion years, more than 6 times all the history there has ever been. The same breath, the same voice, the same simple question, how long would it take to cross? The question never changed. Only the distance did, and watching the distance stretch that one small human sound from 13 days into a length that outlives the universe is, I think, the closest your mind will ever come to actually feeling the size of the galaxy you were born in. Let me set the galaxy against the ladder we have climbed, so its size lands as a comparison and not just a number. We began at the moon, 1 light second away. We reached the sun at 8 light minutes. The edge of the sun's wind sat at most of a light day. The Oort cloud reached a light year and a half. The nearest star stood at 4¼ light years, and that gap alone undid us. And now the galaxy spans 100,000 light years, which means that if you took the gap to the nearest star, the one that reduced our fastest machine to a crawl of 0.06%, and laid it end-to-end across the galaxy, you would need more than 20,000 of those gaps to reach the other side. 20,000 nearest star crossings, laid in a line, and each one already beyond us. That is the width of the wheel we live in, one of hundreds of billions of stars, and it is only one galaxy among an uncountable multitude. And still it is our home, in the largest sense the word can bear. Every star you have ever seen, every star anyone has ever seen with the naked eye in all of human history, lives inside this one galaxy, this single wheel among multitudes. The entire night sky of human experience, all the constellations of every culture, all the stars that ever guided a ship or marked a season or filled a poem, are a tiny local sample of this one structure, drawn from our own small corner of it. We have never seen a single star from any other galaxy with the unaided eye, not one in all of history. Everything is here, in the Milky Way, and the Milky Way is a gap a scream cannot cross in 6 times the life of the universe. And yet we are here, and we can hold the number, even if we cannot cross the gap. We can stand on our small world and work out, with care and honesty, exactly how far it is across our galaxy, exactly how many years a scream would take, exactly how completely the distances defeat us. There is something almost defiant in that, in a creature so small measuring a gap so large that its own voice would outlive the universe trying to cross it. We cannot go, but we can know, and knowing, tonight, is what we came here to do. So let us keep going, out past the edge of our own galaxy now, into the space between galaxies, where we will find that our whole Milky Way, the entire 100,000 light-year wheel we could not cross, is itself only a single member of a crowd, and that the gaps between the galaxies make the gap across our own look small. Part 10. The light on your eye is older than you. Leave the galaxy behind now. Pull back until the whole Milky Way, the entire wheel of hundreds of billions of stars that we could not cross, the structure that defeats a scream for 87 billion years, shrinks in your view until it is a single glowing spiral you could cover with your hand. And look around at the darkness it floats in, and you will find that our galaxy is not alone. It has neighbours, and the nearest large one has a name you know. It is called Andromeda. Andromeda is the nearest large galaxy to our own, another great spiral of hundreds of billions of stars in many ways a sister to the Milky Way. And here is the first thing to feel about it. You can see it with your own eyes. On a clear dark night far from city lights, if you know exactly where to look, you can find Andromeda as a faint smudge of light in the constellation that shares its name, a dim and cloudy patch against the black. Most people who see it do not realize what they are looking at. They think it is a nearby star or a bit of haze. It is not. It is an entire galaxy, a wheel of hundreds of billions of suns, and the faint light landing on your eye has crossed a gap so wide that the number is going to do something to you. Andromeda is about 2.5 million light-years away. Let me build that against everything we have climbed. The nearest star was 4 light-years, and it defeated us. The galaxy was 100,000 light-years across, and light needed 100,000 years to cross it. Andromeda is 2.5 million light-years away. That is 25 times the width of our entire galaxy, just as the gap to the nearest large neighbour. The empty space between galaxies is so wide that you could line up 25 Milky Ways across it, edge to edge, before you bridge the gap. Now here is the thing that I think is the true weight of Andromeda, and it is not a crossing time. It is the light itself. That faint smudge you can see with your naked eye is not Andromeda as it is now. It is Andromeda as it was 2.5 million years ago, because that is how long its light has been travelling to reach you. The light entering your eye tonight left Andromeda 2.5 million years ago. It set out across the emptiness between galaxies before your species existed. 2.5 million years ago, there were no human beings. Our distant ancestors were walking upright on the plains of Africa, early and small-brained, nothing like us, nothing that could have imagined a telescope or a galaxy or a number this large. That light left Andromeda then, when nothing human yet walked the Earth, and it has been crossing the dark ever since, through the entire rise of humanity, through every generation that ever lived, and it arrives tonight, at last, on the wet surface of your eye, older than your whole species. Let that settle, because it changes what it means to look up. When you look at Andromeda, you are not looking across space only. You are looking across time. You're seeing something so far away that its light is a message from before humanity, a photograph developed over 2.5 million years and delivered to you tonight. You cannot see Andromeda as it is now. No one can. The light that would tell us what Andromeda looks like tonight will not arrive for 2.5 million years, long after everyone alive today is gone, long after our civilization has become whatever it will become. We only ever see the past out there. The farther we look, the older the news, until the most distant things we can see are messages from a universe so young it had barely begun. And I have to tell you the part that presses hardest, because it is the same knife we have felt all night. Andromeda is the close one. It is the nearest large galaxy, the friendly neighbour, the least of the intergalactic distances. Beyond it, the gaps only grow. Our galaxy and Andromeda and a few dozen smaller galaxies form a little cluster called the local group, and that group is about 10 million light-years across. And the local group is itself a small member of a larger structure, and that structure is part of something larger still, a colossal collection of galaxies called the Laniakea supercluster, which stretches across something like 520 million light-years. 520 million light-years, just for our local supercluster, one structure among countless others scattered through a universe that dwarfs it. There is a quiet grief in this that I do not want to rush past, because it is one of the real emotional weights of the whole night. To call Andromeda a neighbour is to stretch the word neighbour until it nearly breaks. A neighbour is someone close, someone you could reach, someone whose light reaches you fresh. Andromeda's light reaches you 2.5 million years stale, from a distance nothing we could ever build will cross, and it is the closest large galaxy there is. The universe uses the word neighbour for things that are further from us in space and time than our own species is old. That is the scale we are standing inside. That is how far apart the great islands of stars are kept. There is something coming for Andromeda and our Milky Way, and it sharpens the strangeness rather than easing it. Andromeda is not sitting still at its 2.5 million light-years. It is moving toward us, drawn by gravity across the enormous gap, falling slowly closer over the ages, and in something like 4 billion years the two great galaxies will meet and merge, their hundreds of billions of stars swirling together into a single larger galaxy. And yet, and this is the part that returns us to the theme, even in that collision, almost nothing will actually touch. The stars are so far apart, the gaps between them so enormous, that when two galaxies pass through each other, the individual suns almost never collide. They simply glide past one another across the emptiness, rearranged into new paths, while the galaxies as a whole merge into one. Even a collision of galaxies is mostly a collision of empty space. The distances hold even then. Hold again the strangeness of seeing Andromeda at all, because it is the purest example of the thing we keep meeting, that looking out is looking back. The light on your eye left Andromeda 2.5 million years ago, and has been crossing the dark ever since, through the entire span of human existence, arriving only now. Which means you cannot know what Andromeda is doing tonight. No one can. Whatever is happening there now, this instant, will not be visible from Earth for 2.5 million years, long after everyone alive today is gone and forgotten. We are permanently cut off from the present of everything distant. We live always in the arriving past, reading light that set out before we existed, and the farther we look into space, the farther we look into time, until at the very limit we're seeing the universe as it was when it had barely begun. And I keep returning to the word neighbour, because it will not stop aching. In every human sense, a neighbour is someone near, someone you could reach across a fence, someone whose life touches yours in time. Andromeda is called our nearest large galactic neighbour, and its light is older than our species, and the gap to it is 25 times the width of the galaxy we could not cross, and it is the close one, the near one, the friendly one. If this is a neighbour, then the word has been stretched past anything a human mind would recognise, stretched across 2.5 million years, and an emptiness nothing we build will ever cross. That is the scale we are standing inside tonight. That is how thinly the universe scatters its great islands of light, so thinly that the nearest one is a memory older than humanity, faintly glowing in the dark, calling itself a neighbour. And still, as always tonight, there is the other side of it, and I want to give it to you before we climb the last rungs. That faint smudge is visible to your naked eye. Think about that. A creature on one small world can walk out into the dark, tilt its head back, and catch on the surface of its eye a few grains of light that cross 2.5 million years of emptiness from another galaxy. We cannot go there. We will never go there. But the light comes to us, freely, every clear night, and we have learned to catch it and to read it and to know what it is. We are held in place by the distances, and yet the distances send us messengers, ancient and faint, and we have learned their language. Hold that alongside the grief. Now let us go faster than we have gone all night. Let us stop crawling and become the fastest thing that exists, and see if speed can save us. Part 11. Even as light, you do not arrive. We have spent the whole night measuring these distances in slow things, in cars and screams and walking, and even in Voyager, which is fast for us but crawls against the scale of the sky. So let us do something different now, for the last stretch of the climb. Let us stop being slow. Let us become the fastest thing that exists in the entire universe. Let us become light itself, and see whether speed, real speed, the absolute speed limit of reality, is enough to save us from the distances. Come with me, and let us fly. You are light now. You move at the speed of light, 300,000 kilometers every second, the fastest anything can ever move, the speed nothing with mass can ever reach and nothing at all can exceed. Nothing in the universe will ever outrun you. Let us begin at the Earth and go outward, and let us see how the distances feel when you are the fastest thing there is. You leave the Earth, and in a single instant, in 1.25 seconds, you have crossed to the Moon, the gap that took a scream 13 days. You barely notice it. You keep going, out toward the Sun, and in 8 minutes and 20 seconds you are there, crossing in a few breaths the gap that would take a car 170 years. This feels good. This feels like freedom. You race outward past the planets, past Neptune in 4 hours, out to the edge of the sun's wind in a little over half a day, and you think, perhaps this is how you beat the distances, by becoming the fastest thing there is. You cross the entire Oort cloud, the enormous shell that would take Voyager 30,000 years, in a year and a half, and then you set out across the first real gap, toward the nearest star. And here, even as light, the first change comes. The gap to Proxima Centauri, the nearest star, takes you 4.25 years. 4 years, even at the speed of light, even as the fastest thing that exists. You who crossed to the Moon in an instant now spend 4 years in the dark between two stars, and you begin to understand that speed is not going to save you the way you hoped. You press on. You cross the galaxy toward its centre, and it takes you 26,000 years. You fly on to the far edge of the Milky Way, and 100,000 years have passed. You, the fastest thing in the universe, have spent 100,000 years crossing a single galaxy. And then you look ahead, toward Andromeda, the nearest large neighbour, and you set out across the gap between galaxies, and it takes you 2.5 million years to cross. 2.5 million years of unbroken flight at the absolute speed limit of reality, just to reach the closest large galaxy to your home. And now comes the part that breaks the last hope, so let me say it carefully. You keep flying, as light, across the supercluster, across 500 million light-years and more, past thousands of galaxies, and you begin to reach for the edge of what can be seen, the far horizon of the observable universe, and you discover that you cannot reach it. Not because you are too slow, because you are as fast as anything can ever be. You cannot reach it because the edge is running away from you. The universe is expanding. Space itself is stretching everywhere, all the time, and the most distant regions are being carried away from you faster than you, even as light, can close the distance. You chase the horizon at the speed of light forever, and the horizon flees ahead of you forever, and you never arrive. The fastest thing that can ever exist, given infinite time, still cannot reach the far parts of the universe, because the distance between you and them grows faster than you can cross it. Stop flying now, come to rest, out in the dark between galaxies, and feel what has just happened, because it is the quiet undoing at the top of this whole climb. We tried everything tonight. We tried the car and the scream and the walk and the bullet and Voyager, and they all failed, and we told ourselves that if only we were fast enough, if only we could reach the ultimate speed, we could beat the distances. And now we have reached the ultimate speed. We have become light, the fastest thing that will ever exist, and it is still not enough. Light itself takes 100,000 years to cross our galaxy, and 2.5 million to reach the next, and cannot ever reach the far universe at all, because the emptiness is not only enormous, it is growing. Speed was never going to save us. There is no speed that saves us. The distances are simply larger than motion. There is a truth about being light that I have to give you, because it is one of the strangest facts in all of physics, and it belongs exactly here. For light itself, no time passes at all. This is not a figure of speech. According to the physics that governs our universe, a beam of light does not experience the journey it makes. From the point of view of the light leaving Andromeda, it departs and arrives in the same instant, crossing 2.5 million years of our time in no time at all of its own. The 2.5 million years are what we measure, standing still, watching from outside. For the light there is no duration, no crossing, no waiting. It is emitted and absorbed as a single event. So as you fly tonight as light, there is a sense in which you would feel none of it, would cross the whole universe in what seemed to you an instant, and only we, the still watchers left behind, would count out the ages your journey took. But we are the still watchers. That is the point. We do not get to be the light. We are the ones on the ground, measuring the years, and from where we stand the light takes exactly as long as the distance demands. A second to the moon, 4 years to the nearest star, 100,000 across the galaxy, 2.5 million to Andromeda, and forever, quite literally forever, to the fleeing edge of everything. The universe grants timeless crossing only to the massless, only to light itself, and everything we could ever build has mass, and so everything we could ever build is bound to the slow clock, the clock that makes the nearest star a 75,000-year voyage. We can send light. We cannot ride it. We can only watch it go and wait out the years it takes and know that the light itself felt nothing of the wait. So let the flight settle into its final lesson. We became the fastest thing that can ever exist, and we found that even it drowns in these distances from where we stand, and that even it cannot reach the far universe at all, because the emptiness grows faster than light can cross it. There is no faster. There is nothing beyond light. We have reached the absolute ceiling of what motion can do, and the distances are still larger. This is not a problem waiting for a solution. This is the shape of reality, and we are inside it, small and bound and slow, watching light itself fall short. And strangely, resting here in the dark between galaxies, having flown as fast as flight can go and still failed, there is a kind of peace in it. The peace of finally knowing the true size of the thing, of stopping the struggle and simply seeing. We cannot cross it. Now we know. And knowing is its own kind of arrival. I want to sit here with you in this dark for a moment, resting, the way you rest after understanding something that cannot be ununderstood. We have found the ceiling. It is not a matter of engineering, not a matter of building a faster ship, not a matter of waiting for a cleverer generation. The fastest thing that physics allows still drowns in these distances, and that means the distances are not a challenge to be met. They are a fact to be lived with, like mortality, like time, like the fact that the past cannot be visited. They are simply part of the shape of the universe, and we are inside that shape, small and still and unable to cross it. But there is one more thing to see, one last turn, and it is not more cold. It is the turn that brings all of this home, all the way home, closer than you would ever expect a story about cosmic distance to reach. Let us come back down. Let us come back to your own hand. Part 12. The distances are winning. Before we come all the way home, I have to show you the last cruelty and the last strange gift together, because they are the same fact, and it is the fact that these distances are not holding still. They are growing, and some of what we can see tonight we are watching leave forever. Let me lay out the size of the thing we're standing inside. The observable universe, the total sphere of everything whose light has had time to reach us since the beginning, is about 93 billion light-years across. Now that number should confuse you, and I want you to feel the confusion, because it is a doorway. The universe is only about 13.8 billion years old, so how can the part we can see be 93 billion light-years across? How can we see things whose light would have needed far more than the age of the universe to reach us if it were simply travelling through still space? The answer is the thing that governs this whole final rung. Space itself has been stretching the entire time the light was travelling. The light set out long ago, and while it travelled, the space it had already crossed kept expanding behind it and around it, carrying its starting point ever farther away, so that the objects that sent that ancient light are now far more distant than the light's simple travel time would suggest. The universe is not just large, it is being actively enlarged, everywhere, in every moment, including this one. And here is the consequence that I find genuinely hard to hold, and I have thought about it a great deal. Because space is expanding, and because the most distant regions are receding faster than light can cross the growing gap, most of the observable universe is already unreachable. Not hard to reach, unreachable in principle, forever, even at the speed of light, even with infinite time. Of all the galaxies we can see, only a small fraction, something on the order of a few percent, could ever be reached by a signal we sent today, even a signal moving at light speed. The rest are already beyond a horizon, receding too fast, carried away by the stretching of space itself. We can see them. Their old light still reaches us. But we could never, under any circumstances, send anything to them or receive any reply. They are visible and unreachable at the same time, which is a specific kind of loneliness the mind is not built to hold. Now let me tell you the part that I think is the true emotional centre of this final rung, the thing that turns a fact about cosmology into something closer to grief. Some of the galaxies we can see in the sky tonight are right now in the process of leaving us forever. As space expands and its expansion accelerates, galaxies that are currently visible are being carried toward that horizon, and one by one over the ages they will cross it, and their light will stretch and dim and redden until it fades from view entirely. And here is the knife. The light we are receiving from some of those distant galaxies right now is, in a real sense, the last news we will ever get from them. We are seeing them at the final moment of their visibility, and the message arriving tonight is a goodbye we did not know we were being sent. They are slipping over the edge of what can ever be seen, and the light in our telescopes is the last of them we will ever have. Sit in that with me, gently, because it is a real sorrow, even though it is happening to strangers made of stars we will never touch. We are watching things disappear that were never ours to keep, saying goodbye to places we never visited and never could. And it goes further still. In the far future, in something like 100 billion to 150 billion years, the expansion will have carried every galaxy outside our own small local group beyond the horizon. Everyone, and an intelligent creature living then, on some world, looking up with the best instruments it could build, would see only its own local cluster of stars floating in an empty black, with no other galaxies anywhere, no evidence that the wider universe had ever existed. It would do everything right, measure everything carefully, and conclude that the universe was small and static and utterly alone. The truth would be gone, carried beyond reach by the growing distances, and there would be no way for that creature to ever know what it had lost. Let me take you there, for just a moment, to that far future sky, because I think you should stand under it once. You're on a world 100 billion years from now. You look up, and the sky is black, blacker than any sky you have ever seen, and nearly empty. Your own galaxy, long since merged with Andromeda into a single great cloud of old and reddening stars, hangs around you, and beyond it there is nothing. No Andromeda in the distance, because there is no distance any more that light can cross to bring it. No faint smudges of other galaxies. No Milky Way band of a wider cosmos. Just your own island of dying stars, and past its edge, in every direction, an infinite and featureless dark. That is what the growing distances are building, patiently, over the ages. A universe of islands, each one alone, each one unable to see or reach any other, each one convinced it is all there is. Let me make the growing of the distances concrete, because it is easy to say space expands and hard to feel it. Imagine every point in the universe gently drifting away from every other point, not because anything is pushing them, but because the space in between is itself getting larger, new distance appearing everywhere at once. Nearby, this drift is so slight it means nothing. The Earth is not drifting from the Sun this way, nor our Sun from its neighbours, because gravity holds the close things together against the stretching. But across enormous distances, where there is no gravity strong enough to hold, the drift adds up. More and more space appearing across more and more emptiness, until at the largest scales whole galaxies are carried apart faster and faster, and the most distant ones are receding faster than light can cross the widening gap. The expansion is gentle everywhere and overwhelming across the whole, and it never stops, and it is speeding up. This is why a fraction of the universe is already lost to us forever, sealed off behind a horizon of pure speed. A galaxy far enough away is receding so fast, carried on so much stretching space, that any light it sends toward us can never close the distance, because the distance grows faster than the light advances. We still see such galaxies, because their old light, sent long ago when they were closer, is still arriving. But nothing they do now will ever reach us, and nothing we do now will ever reach them. They are visible ghosts, showing us a past that light still carries, while the living present of those places is already cut off from ours forever. Most of the observable universe is already like this, seen but unreachable, a museum of ancient light hung around us, its subjects long since carried beyond any possible contact. Return with me one last time to that far future sky, and stand in it fully, because it is where the growing distances are taking everything. 100 billion years from now, a thinking creature on some world looks up into a dark that is nearly perfect. Its own galaxy surrounds it, old and red, the merged remains of the Milky Way and Andromeda, and beyond that galaxy there is nothing, no lights, no smudges, no other islands anywhere in the sky, because every one of them has been carried beyond the horizon of speed, and its light stretched away into invisibility. That creature, studying its sky with every instrument it can build, would find no evidence that anything exists beyond its own galaxy, and would conclude, reasonably, carefully, and completely wrongly, that its galaxy is the entire universe, alone in an endless void. The truth would be gone, not destroyed, but carried out of reach, hidden behind the growing distances, and there would be no way left to recover it. That is the universe the expansion is patiently building, and we are watching the early chapters of it in the brief window when the lights are still on. I want to be careful and honest here, because this is speculation grounded in real measurement, not certainty, and the honesty matters. We know the universe is expanding, and we know the expansion is speeding up, and those two facts are as solid as anything in the science. What drives the acceleration we call dark energy, and the truth is that we do not fully understand it, only that its effect is measured and real. The far future I have described, the sky emptying galaxy by galaxy over 100 billion years, follows from the expansion continuing as it appears to be going. It is the honest extrapolation of what we see, and on this channel, when we reach the edge of what is known, we say so plainly, because the not knowing is part of the wonder, not a flaw to hide. We do not know why the emptiness grows, we only know, with real confidence, that it does. But hold the certain part because it is heavy enough on its own. Right now, tonight, most of the galaxies whose light reaches our telescopes are already beyond any possible contact, sealed behind the horizon of the expansion, visible only as old light still in transit. That is not a far future prediction. That is the present state of the sky. The overwhelming majority of what we can see, we could never reach and never signal, not with infinite time, not at the speed of light, because the space between is growing faster than any message could cross it. We live already inside the emptying, already surrounded by ghosts of light from places forever out of reach, and the emptying is only accelerating from here. We simply happen to have arrived early enough that the sky is still full of those ghosts, still bright with the ancient light of 1,000,000 unreachable islands, and that early arrival is the whole of our luck. And now feel the strange gift folded inside that grief, because it is real, and I promised you both halves all night. We are not those far future observers. We got here early. We arrived in the brief window of cosmic history when the other galaxies are still visible, when Andromeda still smudges the dark, when the light of 1,000 distant islands can still reach our eyes and tell us the truth about how large and how full the universe really is. The growing distances will eventually hide all of this, but they have not hidden it yet, and we are here, now, in time to see it, in time to know. We are among the ones who got to look up while there was still something to see. That is not nothing. Against the enormity of the distances, against the cage made of emptiness, against a scream that outlives the universe, we still got to be here, in the seeing time, and to know what is out there before it goes. Now, at last, let us come home, all the way home, closer than home, and find the same emptiness waiting inside your own hand. Part 13. The distance inside you. Come all the way back now, back from the far future, back from the edge of the observable universe, back across the galaxies and the stars and the cold outer shell of our own solar system, back past the sun, back to the earth, back to the room you're sitting in, back to your own body, your own hand resting wherever it rests. We have travelled as far as anything can travel tonight, out to the growing edge of everything, and now I want to end somewhere unexpected, somewhere that will bring the whole night to rest. I want to end by looking at the distance inside you. Reach out, in your mind, and touch something. The blanket over you, the surface beside you, your other hand. It feels solid. It feels like contact, like two things meeting with nothing between them. And it is not. It is one of the gentlest illusions there is. Because when you touch something, your atoms never actually meet its atoms. They come close, and the forces between them push back, and you feel that push as solidity, as touch. But the atoms themselves never make contact. There is always a gap. And that gap at the scale of the atom is not small, it is enormous. Here is the thing that ties the whole night together, the thing I have been carrying toward you since we stood beneath the moon. An atom is almost entirely empty space. At the centre of each atom is a tiny dense nucleus, and around it, far away at the atomic scale, a haze of electrons, and between the nucleus and those electrons there is nothing at all, a gap that is, in proportion, as wide and as empty as the gap between a star and its planets. If you took a single atom and blew it up to the size of a great stadium, the nucleus at the centre would be a grain of rice on the 50-yard line, and the rest, all of it, all that enormous dome volume would be empty. The solid world you are touching is made of atoms, and the atoms are made almost entirely of emptiness. The chair holds you up not because it is full, but because of forces reaching across gaps, the same way the planets are held in their orbits across the emptiness by the reaching of gravity. Do you see what this means? The horror we went looking for out among the stars, the enormous emptiness, the gaps so wide that nothing can cross them, the distance that holds everything apart. It is not only out there, it is in here, it is what you are made of. Your hand, your body, this book of a world you live on, all of it is mostly gap, mostly distance. Mostly the same emptiness we found between the stars, just folded down small. The universe keeps its rooms far apart at every scale, from the space inside a single atom to the space between the galaxies. Emptiness is not something the universe has. Emptiness is what the universe mostly is, all the way up and all the way down, and you are no exception. You are a small warm pattern of mostly empty atoms, contemplating the mostly empty space between the stars, and the two emptinesses are the same emptiness, wearing different sizes. I told you at the very beginning of the night that this was the last time your mind would feel at home, and I asked you to hold on to the familiar distances, the drive across the country, the flight over the ocean, the walk to school. Take one of them out again now, and look at it, because it has changed. That drive across the country crossed a certain number of kilometres, yes, but every one of those kilometres was made of atoms that were themselves mostly empty. So that in a sense you were crossing a distance made of smaller distances, emptiness stacked inside emptiness all the way down. The far and the near are not as different as they seemed when we started. They are the same thing, the same emptiness, the same gap measured with different rulers, and your mind, which cannot hold the distance to Andromeda, is itself built out of that very distance, scaled down small enough to fit in a skull. I do not offer you this to frighten you, and I hope by now you can feel that the fear has quietly turned into something else, because here is where the whole night lands for me, and I hope for you. We are small, and the distances are enormous, and we cannot cross them, and there is no wall we could break to change that, and even light is too slow, and the far parts of the universe are leaving forever, and all of that is true, and none of it is the last word. The last word is this: a pattern of mostly empty atoms on a mostly empty world, in a mostly empty universe, woke up somehow and looked out across the gaps and measured them and felt them and understood them. We cannot go to the stars, but we are made of the same emptiness that holds the stars apart, and we can hold that emptiness in our minds and know it, and even, on a quiet night like this one, find it beautiful. The distances the human mind cannot hold turn out to be the very thing the human mind is made of, and that, in the end, is not a horror. That is the strangest and gentlest kind of belonging there is. Let me make the emptiness inside the atom as concrete as I can, because it is the hinge the whole night turns on. Picture a single atom swollen to the size of a great sports stadium, the kind that holds 100,000 people. Somewhere in the very centre of that stadium, on the middle of the field, sits the nucleus, the dense core where nearly all the atom's matter lives, and at this scale, that nucleus is about the size of a single grain of rice. One grain of rice, in the centre of an entire stadium, and around it, filling the seats and the air and the whole enormous domed volume, nothing but a thin haze of electrons and otherwise empty space. That is the atom. That is what all solid matter is made of. A grain of rice in a stadium, repeated countless times, and the emptiness between them is the overwhelming majority of what you call solid ground, solid walls, solid hands, solid you. So when you press your hand against the surface beside you and feel it stop, feel it hold, feel the reassuring solidity of the world, what you're feeling is not matter meeting matter. You're feeling forces reaching across the emptiness inside and between atoms, the same kind of reaching, the same crossing of a gap that holds the planets to the sun and the stars in their slow orbits around the galaxy. Solidity is not fullness. Solidity is emptiness held in a pattern by forces that reach across it. The chair holds you the way the sun holds the earth, across a gap by a reaching, and the gap in the atom is, in its own proportion, as wide as the gap between worlds. You have never touched anything in your life. You have only ever felt the forces reaching across the distances at every scale all the way down. This is where the night has been going the whole time, and I think you can feel it now rather than just hear it. The enormous emptiness we went looking for out among the stars was never only out there. It is the substance of everything, including you. The same reaching across gaps that lets a galaxy hold together is what lets your hand hold a cup. The same emptiness that keeps the stars unreachably far apart is what fills the atoms of your own body. We are made of the very thing we cannot cross. And so, the horror that opened this night, the horror of distances the mind cannot hold, arrives finally at something quieter and truer, which is that those distances are not foreign to us and not opposed to us. They are what we are. The universe keeps its rooms far apart at every scale, and we are one of those rooms, mostly empty, briefly lit, aware for a little while, looking out through our own emptiness at all the rest. Rest now. The distances are still out there, unchanged, indifferent, enormous. But you have crossed them tonight in the only way anything ever will, in the mind, in the quiet, in the knowing. And that is enough. That was always going to have to be enough, and somehow, tonight, it is.